Hey miners, welcome to the lab for Biomechanics. My name is Alyssa and I'm going to be showing you our facilities and some of the research activities that we do here. Our main focus is on human biomechanics, more specifically kinetics and kinematic data. Kinetics are the study of forces, while kinematics are the features of the motion of the object, such as velocity, acceleration, momentum, and trajectory movement. The main technology that we use in the lab is 3D motion capture technology. We have a total of 10 cameras, and each camera has a capture rate of 120 or 200 frames per second, which is how many pictures of data are collected at 1 second. Now that you know a little bit more about the lab, let's take a look at the lab. This is the Gate Research and Movement Analysis Laboratory, which features 10 3D motion capture cameras and 3 force plates. We use these force plates to capture kinetic data. As you can see, when the participant steps on the plate, the arrows on the screen correspond to how much force she is using when stepping on them. When collecting kinetic and kinematic data, we use markers that are coated with a retroreflective material to reflect light, which can be picked up by the camera. It is important to wear form-fitting clothing. This way, when the markers are adhered to the participant, they are as close to the skin as possible and represent bony landmarks to accurately convey human movement. We also tell participants to not wear anything reflective, as it can be mistakenly picked up by the cameras. In our lab, we focus mainly on the lower extremities, so we will be showing a marker set for lower extremities that is commonly used. The markers have to be adhered to specific anatomical landmarks, such as the lateral knee joint line, calcaneus, lateral malleoli, anterior superior iliac spine, and the sacrum. Then we reinforce with tape so the markers don't fall off when the participant is performing a movement. There are some limitations with 3D motion capture, such as inaccurate placement of the markers, human error, and markers placed on loose-fitting clothing that may not represent accurate anatomical movements. The remainder of the marker set will be completed by the research team member. This is the completed marker set, and the participant is ready to begin with data collection. The first step is to have the participant in the middle of the lab space in a T-pose, so we are able to see all of the markers we have placed on the computer. This is called subject calibration. Once we have calibrated, you can see that as the participant moves her lower extremities, it is captured on the computer screen. The cameras can follow the marker trajectories across the lab space. The participant is now going to perform a counter movement jump. This movement will be important in the following lab assignments. As the participant is performing the counter movement jump, we are able to see this movement on the computer screen. It is important that the forces on each force plate, which are represented by arrows, are of the same magnitude before she begins the jump. Now that we have collected this data, we can export it for further analysis. In our lab, we use a program called Visual 3D, which helps transform the data you saw into a skeleton model. If you have any questions or want to get more involved in the lab, feel free to send me an email. You can also follow us on Instagram, Facebook, or Twitter to get more up-to-date information about our research activities. Thanks for watching!